Good day guys, this is your tutor engineer. Today we'll be doing an exam question on grade 12 on the rate of reaction. A certain antacid company needed to determine the rate of reaction of magnesium carbonate, neutralize stomach acid, which is hydrochloric acid. The balance equation for this reaction is as follows. They conducted the following experiment. So this was experiment 1. We have the state of division, which is powder, and then we have the concentration of hydrochloric acid 0,1. You have the volume of carbon dioxide, which is the one of the product of the reaction 0,05, and then we have got the time. So this was experiment 1. So basically here you have the powdered magnesium carbonate, and then this is the syringe that is used to collect the gas as one of the products of the reaction. Now let's have a look at experiment 2. Experiment 2, we have everything the same except for the state of division. Instead of a powdered magnesium carbonate, you have marble chips, and then the time is much longer for the reaction to take place. Okay, now let's get to the questions. The first question is define the rate of reaction. Basically, the rate of reaction is the amount of a product produced per unit time. That's what the rate of reaction is. In this case, for instance, carbon dioxide is being produced, so it will be the measure of the amount of carbon dioxide gas produced per unit time. Then 5.2.1, the result of the experiment 1 and 2 was compared. Write down the independent variable. So the independent variable in this experiment is the state of division. So if you don't want to write the state of division, you can just write total surface area of magnesium carbonate. Remember, on one part, experiment 1, we had powder, and then experiment 2, we have marble chips. So that would be our independent variable. Then the dependent variable would be the rate of reaction. Or if you don't want to write rate of reaction, you can just write the definition of the rate of reaction and say it's the amount of the carbon dioxide gas produced per unit time. That would be a dependent variable. So most often, a rate of reaction is going to be a dependent variable. Normally, to understand this, the independent variable is normally on your x-axis. That is the state of division. And then the dependent variable is normally on your y-axis, rate of reaction. That's the parameter that is being measured in the experiment. Now 5.3, calculate the rate of reaction for experiment 1 and 2. Okay, for experiment 2, let's work it out. Okay, let's look at the units. We need to present the rate of reaction in terms of dm cube per second. Now let's calculate for experiment 2. So here we'll say the rate of reaction, since you need to present it in terms of dm cube, which is the volume, we'll say change in volume divided by change in time. So here the change in volume for the carbon dioxide gas in dm cube is 0,05 dm cube divided by the time in seconds is 29. So here the rate of reaction, so putting that on the calculator, 0,05 divided by 29, I get 0,0017 dm cube per second. Now let's do the same for experiment 1. The rate of reaction will say it's the change in V divided by change in time. The volume is the same for experiment 1 and 2, and then the time is 12 seconds. So putting that on the calculator, get 0.004167. So that's dm cube per second. Okay, now let's go over to the next question. I wanted you to realize something just before we go to the next question. You realize that the rate of reaction here is 0.017, which is much less than the rate of reaction in experiment 1, which is 0.04. So this one is much higher because the state of division, and it took much less time for the reaction to complete, and that is why. Now let's go to the fourth question. The fourth question says, use the collision theory to explain the variance in the rate of reaction between experiment 1 and experiment 2. I've just explained it to you. Experiment 1 uses powder and experiment 2 uses maple chips. Therefore, in experiment 1, you've got more surface area. Therefore, there will be more effective collision per unit time, and the kinetic energy under experiment 1 will be much higher than the activation energy. That's why experiment 1 will have a higher rate of reaction than experiment 2. So that is what I would have written here for question 5.4. I hope you understood that part. Now let's go to 5.5. Another experiment is carried out using 23 grams of magnesium carbonate. So we'll call this experiment 3. This is number 3. You've got 2 experiments. This is the third experiment. So magnesium is still a powder, and the same concentration of hydrochloric acid was used, which is going to be 0.01. Determine the limiting reactant in this experiment if the reaction takes place in a 5 dm cube container. So that's the volume. So what is the limiting reactant? In order to identify the limiting reactant, you have to compare the number of moles between magnesium carbonate and hydrochloric acid. The substance that uses the least number of moles between these two reactants is the limiting reactant. Okay, let's use that in a calculation. Let me use experiment 1 for example. Okay, you already have magnesium carbonate reacting with hydrochloric acid. This is the balanced equation for the reaction. So remember, magnesium carbonate is 23 grams. And then when it comes to hydrochloric acid, let me kind of use a different color from here. When it comes to hydrochloric acid, the concentration is 0.1, but our flask has got a volume of, we're given that our volume is going to be 5 dm cube. And then we have to identify a limiting reactant. So let's calculate the number of moles since we have the concentration, which is 0.1 mole per dm cube for hydrochloric acid, then you've got the volume. We'll use this formula. C is equal to N over V. So this is, remember, this is for hydrochloric acid. The concentration is 0.1. The number of moles, that's what you need to calculate. The volume is 5. So the number of moles is 0.1 times 5, which is going to be 0.5 mole. This is 0.5 mole of hydrochloric acid. Now let's look at the balanced equation. That means here 0.5 mole of hydrochloric acid was involved in the reaction, but then this reaction has got 2:1 ratio. So that means the corresponding number of moles for magnesium carbonate that reacted with hydrochloric acid will divide it by 2 to maintain the same ratio. So that will give us 0.25 mole of magnesium carbonate. Now let's calculate the number of moles that were actually used in this reaction using this mass, 23 grams. Okay, let's come back here. The formula that you'll use is N is equal to mass divided by molar mass. We'll calculate the number of moles. So remember, this now is for magnesium carbonate. The mass is 23 grams. That one we are covered. And then the molar mass, that's the one you need to calculate from the periodic table. I've got the periodic table here. In our periodic table, we have magnesium, we have carbon, then we have oxygen. Magnesium is 24, carbon is 12, then oxygen is 16. So I'll calculate the molar mass separately. So the molar mass for magnesium carbonate is 24 plus the carbon is 12, the oxygen on the periodic table is 16, and then we've got 3 oxygen atoms, so I'll write a 3 here. So calculating that, it gets 16 times 3 plus 12 plus 24, that gives me 84. The unit is grams per mole of magnesium carbonate. Okay, now I can work out the number of moles. That's 23 grams. The molar mass is 84. Then the number of moles is 83. Sorry, it's 23 divided by 84. I get 0.27 mole of magnesium carbonate. Remember, I only need 0.25 mole of magnesium carbonate, and I actually have 0.27 mole of magnesium carbonate. So it means magnesium carbonate is in excess by how much? By 0.27 minus what I need, which is just 0.25. I actually have 0.27 and I need 0.25. So that means magnesium carbonate is in excess by 0.024 mole. So since magnesium is excess, the answer would be the hydrochloric acid is the one that is a limiting reagent. So that's it for this particular question. If you like this video, please hit the like button and subscribe. Cheers.